In this lesson, we're going to learn about the basic counting principle. The basic counting principle is basically a shortcut for tree diagrams. And basically what it is you, to find the total number of outcomes in a situation, you can multiply the number of choices for each option to find the total number of outcomes. Okay, so I'll show you some examples of what So if you take a look at this first situation, it says a ballot offered 3 choices for president, A, B, C, and 2 choices for vice president, M and N. How many choices for a combination of the 2 offices did it offer? Well, our original strategy for doing this is to draw a tree diagram. So if we did the tree diagram, we'd have A, B, and C, and then 2 choices for vice president would be M and N. So you draw that for each. Oops, I'm sorry. That's not, that should be an N. And to find the total choices, we would count them. 1, 2, 3, 4, 5, 6. I'm sorry, the combinations, we'd count them. So there are 6 combinations because when you count them up, there are 6 combinations. Okay, well, the basic counting principle is a shortcut for that. The first option is for president, and there are 3 choices. And the second option is for vice president, and there are 2 choices. So you simply multiply 3 times 2, and that gives you 6, which means there are 6 combinations. So that's the way to do it really quickly without actually drawing the tree diagram. Okay, so let's look at another example. The Cougar baseball team has 4 pitchers, pitcher 1, 2, 3, and 4, and 2 catchers, catcher 1 and catcher 2. How many pitcher-catcher combinations are possible? Well, our old strategy, we would draw a tree diagram. So we'd have P1, P2, P3, and P4. And then we'd have 2 catcher options. So we'd have catcher 1, catcher 2, catcher 1, catcher 2, catcher 1, catcher 2, catcher 1, catcher 2. And you'd count up. There's 1, 2, 3, 4, 5, 6, 7, 8 combinations. And so that's how you would find the total number of combinations. But if we use the basic counting principle, you can see that there are 4 choices for pitcher and 2 choices for catcher. So you just multiply those. 4 times 2 gives you 8. So there are 8 total combinations. So the basic counting principle is just a real shortcut. For examples, and I'm not even going to draw the tree diagram for these, and we'll just use the shortcut. So this first one says there are 5 roads from Allen to Baker, 7 roads from Baker to Carlson, and 4 roads from Carlson to Dodge. So we're going from Allen to Baker to Carlson to Dodge, okay? How many different routes from Allen to Dodge by way of Baker and Carlson are possible? So basically, how do you get from Allen to Dodge going through each of these 2 other cities? Okay, and they give you the different road combinations here. So to draw a tree diagram of this would be really, really big. So instead of doing that, we're just going to multiply 5 times 7 times 4. 5 times 7 is 35, and 35 times 4 is 140. So there are 140 routes that would be possible to do this. Okay, looking at one more example, drapery is sold in 4 different fabrics. Each fabric comes in 13 different patterns. Each pattern is offered in 9 different colors. How many fabric, pattern, color combinations are there? Okay, so again, what we're going to do is look at our choices. There's 4 different fabrics. There's 13 different patterns and 9 different colors. So we're going to multiply those all together. Okay, so I'm going to do 4 times 13 times 9. and we get 468. So there are 468 combinations that we could make with these different options. So again, that's a big shortcut, because to draw a tree diagram with 468 combinations would be huge. So that's the way that you can use the basic counting principle.